calculate the EDL closed line around the contour shown in the figure. This is a figure like this. We have X, Y, 1, 1. Okay, so from 0 to 1, from 1 to X equals 1 to Y equals 1, then from Y equals 1 to 0. Okay, so now we have E. We have to find first we are looking for DL, same way, DL for the first case, from we call A to B, for example, and B to C, C to A, from A to B. Okay, dr equals to dy is 0. dy is 0 in this case. dy is 0. So dl is dx in the direction of x. The lone variables is x. Okay, what about E? If y equals 0, so E equals this one is 0, x square plus 0 in the direction of y, so x square in the direction of y. Now E dl, we have dl in the direction of x and E in the direction of y, so E dl equals 0. Okay, direction, perpendicular directions. 2, from A to B, then from B to C. Now from B to C, we have a constant equals 1. So E equals x, y, the direction x, y, so y in the direction. E equals y in the direction of x, because x equals 1, plus 1 plus 2y squared in the direction of y. Okay, so we put x equals 1 in the first equation. Now dl in this case is small dy, the direction of y. Why? Because x is constant, so dx is 0. Now EDL is x times y is 0. Okay, so we have just the second part. So it is 1 plus 2y squared dy. Okay, now it's equal to y plus 2 over 3y cubed from y is varying from 0 to 1. Okay, I'm sorry because of the storage. Okay, so we said that stopped at this level, so we have it's y plus 2 over 3y cubed from 0 to 1. So from 0 to 1 is 1 plus 2 over 3. We found 5 over 3 as a result. Okay, and the first one is 0. The third path, we have dl in the third path is dx plus dy, dx plus dy. In this function we have 0, 5, 0, 5, 1, 1, 0, 0. So in this path we have y equals to x function, so dy equals to dx. Then inside our function E we put x instead of y, so x dot x, so x square, direction of x, plus x square plus 2y 2x square, so it's 3x square. Then dot dx, which is dl, is dx in the direction of x, plus we said that dy equals to dx, so dy you can write dx in the direction of y. So now the result is x squared times x squared dx, the direction of times direction of x, direction of y, dot direction of y.
Okay, so it's x squared dx plus 3x square dx. Okay, this line from the 1x from 0 to 1, or from 1 to 0, sorry, this path from 0 1 to 0 1 to 0. Okay, it is x 3 over 3 plus 3 x 3 over 3 from 1 to 0, so it is minus 1 over 3 minus 1, it's minus 4 over 3. We add them.
So the over the closed surface, EDL is 0 plus 5 over 3 minus 4 over 3. So it is 1 over 3. This is the final result. Now, the second point, second method is the curl of E ds. This is the ds, sorry, ds. This is Stokes theorem, okay? Stokes theorem, just to show it again. We did it in previous video. So Stokes theorem is ADL, or closed line, equals to the curl of A ds. Okay, so the curl of A of E, sorry, ds. Yeah, in this case A, in some example of A, and this one is E. Now the curl of E in the Cartesian coordinate, we have x, y, and z. So d over dx, d over dy, d over dz. Then we have E. What is our E? This is E. Okay, so in direction of x we have xy. The direction of y is x squared plus 2y squared. In the direction of z is 0. Okay, now d of dx, d of this function over dx is 2x. Okay, is I can write it 2x minus d over dy of this is x. So it's equals to 2x minus x in the direction of z. Okay, what about it plus the direction of x? So d over dy 0 minus 0, so 0 in the direction of x, plus in the direction of y, the y direction, so we have d over dx of 0 and d over dz of xy is 0, so it's 0 in the direction of y. So the result is x, 2x minus x is x, direction of z. This is the curl of E. Okay, what about our ds? ds, I show it again, y, x. Okay, so ds is dx dot dy, but our y is a function of x. Okay, so ds is dx dy, and of course we are in the xy plane, so ds follow the direction of z. Okay, then the function now, so it's double integral over the surface of d, the curl of E ds equals to x z. We don't need to put z because z is 0, but I will write it again. Dx dy c. Okay, so it's double integral of x dx dy. We said that y is a function of x, so I will integrate. I have to find the integral of dy first, so it is x dx dy is y from 0 to function of x. Okay, for y is from 0 to x, from 0 to x. Now so it is x dx dot x, so it's the integral of x squared dx from when our x is from 0, the variable x is from 0 to 1. Okay, 0 to 1, it's function of x, so it's x cube over 3. From 0 to 1 it is 1 over 3. Okay, we have the same result, 1 over 3. This is the end of the exercise. Thank you. So the same question for a vector field E, given vector field E. Calculate d e dl, the closed surface. Okay, so we have to find it from A to B, B to C, C to A. A to B. A to B, we have y equals 0, and dl is a function of x, is dx in the direction of x, and now E is 0 in the direction of x, x squared in the direction of y. So the same as the previous one. We have dm in the direction of x and y in the direction of y. So E dl is 0 from A to B. Is 0. Then from B to C, from B to C, we have x is y is a function of x, so we have y equals to the first value is 2, and we have minus the direction, negative direction. It's 2 plus 2 minus x. So dy equals, dy is minus dx. Okay, so dy over dx is minus 1. Okay, so dy is y minus dx. Okay, what about our E? Is x times minus x plus 2 in the direction of x plus x squared plus 2 minus x plus 2 square in the direction of y. Okay, then we have the I forgot to write dl, sorry, so I can write dl is dx in the direction of x minus dx in the direction of y. This is dl. Okay, now E dl is the direction dx, so it is minus x squared plus 2x, this one, first one, dot d times dx, plus x with x, y with y. So minus, sorry, with this minus x squared plus 2x squared minus x plus 4, okay, dx also with this minus dx. Now we write it again. It's
minus x square minus x square with this minus 2x square, so it's minus 4x square, and then 2x minus with minus is 4x, so it's 6 no, dot 2, so it's minus 8 plus 2 is 10x. Then the numbers we have minus 2 times 4, so it's minus 8, all of this dx. Okay, now we can find the integral of e dl. So x vary from, in this case, from 2 to 1. Okay, b is set at 2 to 1. Okay, 2 to 1 of it is minus 4 over 3x3 plus 10 over 2x squared minus 8x from 2 to 1. So it is, after calculation, so with 1 minus 4 over 3 plus 10 over 2, which is 5, minus 8, so 5 minus 8 is minus 3, so it's minus 4 over 3 minus 3. Okay, what about 2? Minus 2 is 2, so 8. Okay, 8 times 4, so minus 32 over 3 plus 2, so it's 4 times 10, 40 over 2 is 20 minus 16. Okay, so the result is, this one is 4. Okay, it's 4. 4, so it's 4 with this minus 4 minus 3, so it's minus 7, and minus 4 over 3 plus minus with minus 32 over 3 is 28 over 3. Okay, this is
a result. Okay, what about this third part from C to A? From C to A is similar than the previous example. We have y equals to x, dl equals to dx plus in the direction of x plus dy in the direction of y. So e dl 3, okay, this is dl3 for example, dl2 and dl1 is what about e? With e we put x instead of y, so x square the direction of x plus x square plus 2x square is 3x square in the direction of y. Okay, this one times dot dl. Okay, so it's x coordinate x square with dx dx. Sorry for this, dy, if we have y equals to x, so dy over dx is 1, so dy equals to dx. Okay, so in this case I can write dx instead of dy, so x squared dx plus in the direction of y 3x squared dx. Okay, now the result is 4x squared dx. Okay. The integral of dl3
dl3, x is from 1 to 0. It's 4x3 cube over 3. So it is minus 4 over 3. Okay, I add, so the integral of EDL, I sum these numbers, minus 4 over 3, and the first one is result is 0, plus the second one is 28 over 3 minus 7. Okay, so the final
is 1. Now we found the same calculation using the curl of E ds. Okay. So in this case we have two surfaces. The first one with this function and the second one with the second function. So dx, dy, following this function. Okay, so the curl of E over the surface. So the curl of E equals the ds, equals to the curl of E ds1 plus ds1, this first surface with this function, plus curl of E for the second surface ds2. Okay, it's not the same function, so we have to divide it over two parts. Okay, now the curl of E, we did it in the previous example. Where is it? So this one. Okay, curl of E, we found it's x in the direction of z. Okay, it's x in the direction of z. Now ds1 is dx dy in the direction of z. So the same ds, but the integral differ. Okay, so ds1 is dx times dy, but our function y is not the same as the second function. Okay, so dx dy, then curl of E ds is x dx dy. Okay, for ds1, so we did it, we start from dy, which is a function of x. It's a function of x from, in the first one, x y, first function y equals to x. Okay, and the second function y equals to minus x plus 2. Okay, so from 0 to x, it is x it's x dx. Okay, now the integral of x is from 0 to 1, so the result is x squared dx from 0 to 1, x cubed over 3 from 0 to 1. It is 1 over 3. This is the first result. The second one, the curl of E ds2 equals to the same x dx dy. Now our dy is from, it's x dx y from y, our y is always from 0 to the function. Okay, so from 0 to the function, so it's from 0, which is function of x minus x plus 2. Okay, so it's integral of x minus minus x plus 2 dx. It is minus x squared plus 2x. X vary from 1 to 2. So it's minus x cubed over 3 plus x squared from 1 to 2. So it's minus for 2 minus 8 over 3 plus 4 minus 1 over 3 plus 1. So the result is minus 7 over 3 plus 3, which is it's 9 over 3 minus 7 over 3. So the result is 2 over 3. Okay, we add them, we found what? 1. Okay, so 1 over 3 plus 2 over 3, we found the same result as the previous one, which is 1. For the final result, we have the curl of E ds equals to 1 over 3 plus 2 over 3, the two surfaces, it's 1. And we have in the previous result EDL, which is the summation, is EDL is over closed surface is 1. So sorry, EDL equals to the curl of E